In case you haven't already figured it out, 2 to the 5th is 32. Knowing that, what's 2 to the 6th? I'm guessing at this point you probably didn't use a calculator, although some of you might have wimped out and done so. You probably didn't say, well,
2 times 2 is 4, times 2 is 8, times 2 is 16.
Yeah, you'd have messed that up, probably. You probably multiplied 32 by 2. And in so doing, you got 64. With that in mind, what's 2 to the 4th? Well, most of you probably know that 32 divided by 2 is 16. You don't need to do any magic here. You know what 2 to the 3rd is, hopefully, but if you don't, you were probably reminded by the 16. And certainly you know what 2 to the 2nd is. 2 to the 2nd is 4. Notice that while you probably didn't, you could have divided 8 by 2 to get the 4.
And 2 to the 1st, well, my goodness, that's 2.
Notice again, 4 divided by 2 is 2.
With that in mind,
What's 2 to the 0? I know at least one person in watching this video was thinking, well, 2 to the 0 is 0. And I get that logic, but it's not. If we just follow this pattern, 2 to the 0 is 1. Now, I know you don't like that. Honestly, I have in my life had the privilege of speaking to a wide variety of really amazing world-class mathematicians, and I've often asked them to help me make sense of this for my junior high students. Normally, the answers I get are, well, there's all sorts of rules that fail if it doesn't, it has to equal 1. Or they say, well, just look at this pattern. Or there's 100 reasons that they give, and none of them are particularly satisfying. You're just going to have to live with it. 2 to the 0 is 1. This also works for 5. 5 to the 2nd, as you know, is 25. 5 to the 3rd can be found by doing 25 times 5. Which, what are 5 quarters worth? 5 quarters are worth $1.25. That's what 5 to the 3rd is. 5 to the 2nd is 25.
So 5, not to the 11th.
5 to the 1st is 5. 5 to the 0 is 5 divided by 5, which is 1. Turns out that no matter what this base is, by the way, this is called a base. That's the exponent, and that is called the power. Any number raised to the 0 is going to be 1. And I know you don't like it. Sorry, it's true. Okay, a little reminder.
2 to the 2nd was 4. And if we divide that by 2, we can figure out that 2 to the 1st is 2. And if we divide that by 2, we can get 2 to the 0 is 1.
Let's keep going. Following this logic, what is 2 to the negative 1? Some of you are refusing to look at the pattern, and you're just saying, oh, negative 2. And the answer is no. Look at the pattern. What's 1 divided by 2? Well, if you type 1 divided by 2 in your calculator, you get 0.5. But that's not nearly as useful as 1/2. Because 1/2 is going to be really instructive as we move forward. 1/2 divided by 2. Think about having a half and cutting it in half. What's 1/2 divided by 2? Why, yes, it's a 4th. 2 to the negative 3rd is an 8th. 2 to the negative 4 is 1/16. Divided by 2, divided by 2. 2 to the negative 5 is 1 over 32. I hope you're seeing the pattern. Here's a little reminder. Here's our sheet from before. Hey, do you see those numbers? All those numbers from before are reappearing. In fact, what I want you to notice is 2 to the negative 5 and 2 to the positive 5. Oh, in elementary school, you learned the word reciprocals. In 7th grade, you learned the expression multiplicative inverse. Look at 2 to the negative 4 and 2 to the positive 4. 2 to the negative 3rd, 2 to the positive 3rd. 5 to the negative 1 is going to be 1 divided by 5. Now again, go ahead, type it in your calculator. You'll get 0.2, which is 2/10, which simplifies to be 1/5. If we divide by 5 again, 1/5 divided by 5, if you type 0.2 divided by 5, you get 0.04. That number is 1/25. I'll bet you can guess what 5 to the negative third is. That's right. It's 1 over 125. 5 to the negative 4. Want to take a stab at it? 1 over 625 is correct. And again, I want you to notice that 5 to the negative 4 and 5 to the positive 4 are multiplicative inverses of each other, as are 5 to the third and 5 to the negative third. If that is the case, what do you think 7 to the negative second is? Yes. Yes, it is. It is not negative 49. It is not 1/14. It is 1 over 49.
Well, that sure is easy, isn't it?
This brings us to a whole genre of fun little exercises.
Like 2 to the negative third plus 4 to the negative 2. Oh, yuck, yes.
That's right, order of operations problems. Now, 2 to the negative third, 2 to the third is 8. 2 to the negative third is 1/8. 4 squared is 16. 4 to the negative 2 is 1/16.
So we get 2/16 plus 1/16.
Which is 3/16. Isn't that fun? And here's a more elaborate order of operations problem. Now, this one's kind of fun because you can actually, if you do it in your calculator, this works out to give you an answer pretty quick. That's pretty easily translated. This is 3 times 1/25 plus 1/4. That's right, we do exponents first, and then we do the multiplication. So this becomes 3/25 plus 1/4. This is 37/100. If you type that into your calculator, you will get 0.37. Now, there is an order of operations problem that I want to talk about before I set you free, and it is 2 to the 5th times 2 to the negative 4th. 2 to the 5th is 32. 2 to the negative 4th is 1/16. If we multiply these together, we get 32/16. And we simplify that, we get 2. It should strike you that that's the base. How did that work? Well, 2 to the 5th is that. 2 to the negative 4 is that. Now I am going to divide the numerator and the denominator by 2. Bump, bump. I'll do that again. Divide the numerator and the denominator by 2. Divide the numerator and the denominator by 2. Divide the numerator and the denominator by 2. I'm left with just a 2 up top. What is 11 to the 7th times 11 to the negative 8? Good, try that. You should give your answer in fraction form. I'll wait. I hope you got 1/11.
Whoops.
And what we can do is we can divide the top and the bottom by 11 to the 7th.
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7.
This 11 didn't get canceled out. This becomes a 1, this becomes a 1, that becomes a 1, that stays 11, and you get 1/11. That'll be handy when you do tonight's homework. Have a good time.